All right, so we have now covered the theory behind our handle player input method. Now we're going to actually get that coded in. Let's just jump right in.
All right, before we go to the handle player input method itself, I want to knock out these public floats that we're going to expose.
Well, sure, the things we're going to need as a part of this method.
Yep, and we're going to need an X mouse sensitivity. And
things are turning red. Could it be that IntelliSense is working for
I
me?
think so. I think maybe possibly the sensitivity or IntelliSense Fairy came by in between videos.
Awesome.
And fixed this problem for me, which was very nice of them. I'm going to duplicate this X mouse sensitivity and change it to a Y. Also defaulted to 5.
Okay.
And I'll, do it one more time. This time I'll change it to mouse wheel sensitivity. Also defaulted to 5.
Okay.
Now we also said that we needed a min and max limit. So let's create those. So public float Y min limit. I'm going to default this to -40.
Now, these are some magic numbers right now?
Mm-hmm. But you can override them if you choose so.
Okay, yeah.
So this is Y max. Pretty much all of these preset numbers, the defaults that I'm putting on, are magic numbers that I've just, through trial and error, have come up with that work well for this example.
But I mean, they're exposed anyway. So.
Yes. They're not truly buried in where you can't get to them and change them without changing the code. So that will give us our 5 fields that we need to expose to actually code out handle player input. So here's handle player input. Let's begin by checking if our left mouse button or right mouse button, is down. I'll get it. So if input dot get mouse, let's type it. There we go. Mouse button 1 stands for the right mouse button.
Right, it's 0 based.
Right.
So
and
0 is left mouse, 1 is right mouse,
and 2 is the middle mouse button.
Middle mouse, right.
Yep. So and it'll return a true if that button's down, false if it's not. So I'm just going to check if get mouse button 1 is true, then I know the mouse button is down.
Right, and you don't even have to have like an is or equal to true. It's just the fact that it is down will return true.
Exactly. So now that I know that the mouse button is down or not down, I'm going to code in the part where when the mouse button is down, we're actually going to check the mouse axis.
You could throw a comment in there and say that you're now going to,
I could.
I'm just saying.
So the mouse, or the right mouse button is down.
Look at you go with the RMB.
Yeah, well, you got me hooked on it.
Like the Maya people, man.
Yeah. So it is down. Get mouse axis input. So the first one that we're going to check is going to be the X axis.
Axis?
Yeah, that too.
Yeah.
That's what I meant. So mouse X is going to increment, so it's going to be plus equals our input dot get axis.
You're good. Yeah.
It's one or the other. I always get them wrong.
Oh yeah.
The one that I'm specifically looking for is mouse X. And then
that would come straight in from Unity's input manager.
Yes. And I'm going to times this or multiply this by our X mouse sensitivity.
Oh yeah, that's right. That's right. That's right.
Yep.
Sorry, I got confused.
Now, our Y is pretty much the same thing. So I'm going to duplicate it, switch mouse X to mouse Y.
But because we're flipping the direction of the mouse, you're going to end up wanting to invert that.
Yep. So I'm going to have to invert this.
Yes.
And then multiply it by the Y mouse sensitivity.
Nice.
So this is going to increment or decrement depending on the direction of your mouse, and whatever Y is automatically going to invert it.
Okay.
So the next part that we would do normally, and I'm going to leave out for now, but I'm going to comment it so we can come back to it.
You're using comments. I'm so proud.
Well, I try to, every once in a while, just throw people off.
Right.
So
I know this is going to freak you guys out, but I'm actually going to tell you what the code's doing.
yep, it's
Right.
like, well, I am telling them what it's doing.
What is it?
So what we're going to do is this part of the code, when we come back to it, this is where we're going to clamp or limit our Y or mouse Y rotation.
Okay.
So this is where we'll limit mouse Y. We'll come back to it. So assuming that we have limited our mouse Y, the next step would be to get the input from the mouse wheel. But we need a dead zone. So we'll come back up to the top of our handle player input. We'll set a var for dead zone. And I'll put in a value of 0.01. This should be good in most cases. If you find that it's not enough, you can raise or lower it accordingly. But I've found pretty much 0.1 has worked on every machine I've ever played on.
Okay.
So we'll leave it there. So we need to verify whether or not we're outside of this dead zone. So what we're going to look for is input, get axis again. This will be the mouse scroll wheel, and then we're going to check to make sure that it is less than our negative dead zone, or it's going to be greater than our dead zone. So I'll take this, copy it, duplicate it, remove the minus sign, and reverse our sign. So we're checking to make sure whether or not our mouse wheel axis is returning a value that is greater than the negative dead zone or greater than the positive dead zone.
Okay.
So we're actually outside of our dead zone. So if our value is outside of our dead zone, we need to do some calculations with it. Now we said that we want to store the value in desired distance. So desired distance is going to equal math F, and we're going to clamp, and we need to get our current distance. We're going to subtract our input dot get axis dot scroll wheel here. So we're going to subtract the value that we get from our mouse wheel input times our mouse wheel sensitivity. So this is where we multiply our mouse wheel sensitivity by our result and subtract it from distance.
All right.
Now, because we're inside of the clamp method, we have to specify our minimum value, which is distance min, and our maximum, which is distance max. And I can end off that whole method. Or not method, but that whole, well, it is a method call.
Yes.
So,
yes.
But that whole statement, so we'll end it off with a semicolon.
Okay.
So, believe it or not, with the exception of going and coding in the limit stuff, all that discussion, that big long theory discussion, is wrapped up in this little bit of code.
That's how it goes, isn't it?
Yep. So, but knowing the theory behind it is what makes it simple.
Sure.
It's like, if you didn't know the theory, then like trying to figure this out for the very first time. It took me a very long time. So, but we still need to limit our mouse Y.
It didn't take you that long.
Well, weeks.
Nah.
So, but we still do have to limit mouse Y. To do that, we need to have to create our helper class.
Okay.
We haven't done that yet. So what I'm going to do is over here to the right, under our scripts folder, I'm going to right click, I'm going to hit add new item, and I'm going to pick a class, and I'm going to name this class helper. Hit add, and we're going to get a base template. Now, I know that some of the stuff that I need is available right here. So using Unity Engine, I can copy and paste that, or I could type it out. It doesn't matter. So I'm going to need to use the Unity Engine for some of the stuff that I'm going to use. So I'm going to put that in right now to get it ready to go. Now, we don't need the namespace stuff. This is a typical convention that you use with .NET programs or C#. But because this is a Unity program, it doesn't use namespaces. So we're going to remove that. So we don't need it. We also want to make our helper class a public static class. So we're going to set this as a public static, and now we can actually program our clamp angle method. So to do it, we're going to make this a public static method, but this is going to return an angle, so it needs to return a float, and we're going to call this clamp angle. Now we know that we want to take in 3 parameters into this method. The first one is going to be an angle of type float. We need a minimum limit and a max limit. So I will use a float min and a float max, and those are our arguments. You know, I can put some curly braces or squiggly braces, whatever you prefer. And we had mentioned that part of the functionality of this method is to not really normalize, but to make sure that whatever angle you send into it is recalculated to a range of between -360 or a positive 360.
Remove any excess full rotations.
Right. So we're going to do a do while, and the do while is basically going to say as long as angle is less than -360 or angle is greater than 360, continue to keep doing this. Now we're using a do while because we want this to run at least once.
Okay.
So the first time you're always going to run it at least once. If it comes through and it evaluates with no problem, it's not going to do anything, but it's always going to go and look at least one time. So what does it do inside? Well, what it's going to do is it's going to check the angle, and it's going to check to see if this angle is less than -360. If the angle is less than -360, it's going to take the angle and it's going to add 360 to it. Then it's going to look to see if the angle is greater than 360. And if the angle is greater than 360, it's going to subtract 360 from it.
Right, and that's just getting rid of those full revolutions.
Exactly. So if we're at 4 or 5 full rotations, this will actually run 4 or 5 times to get the angle back down within its range. So that will get us between -360 to between -360 and positive 360. We still haven't clamped though, so we need to do a clamp, and because this is going to return a float, I'm just going to call the return here, and what I'm going to return is going to be the output of the mathf clamp function or method, and what I'm passing in is going to be our angle followed by our minimum value, which we called min, and our maximum value, which we called max. And that is all we need for our clamp angle. So we're going to build it and make sure there's no errors. Jump back to our TP camera class. Go down to where I put this really cool comment that says this is where we're going to limit mouse Y, and we're now going to limit it. So we're going to say mouse Y is equal to our helper class dot clamp angle. We only have one method in there right now.
Right.
We're going to pass in mouse Y, and we're going to send our minimum. Our minimum is Y min limit, and we're going to send our maximum limit, which is Y underscore max limit. So that will send in our mouse Y rotation, our Y min limit, our Y max limit, and it will return back the clamped value if it exceeds it, or the value that we sent in if it doesn't have to clamp.
Sounds good.
So going to build it out one more time, check for errors. There are no errors, so we still can't attach this to anything in our game. We can't test it yet because we still have a few more methods that we have to go over the theory and then code out.
That's right. I was actually going to mention that. We haven't actually been in Unity for a while, but we're not at a stage where anything that we have is testable. So we just got to kind of keep marching forward. And in the next videos, we're just going to progress with our TP camera functionality, this time taking a look at the desired position, which was the second part. If we take a look in late update, We just took care of handle player input, which was the first method that we called. Next, we're going to take care of calculate desired position, which is our second one. And that is going to have another method of its own that we're going to have to analyze. But more on that once we go over that theory. So that's going to wrap things up for this video. Thanks for watching.